In video number 12, we have discussed step 1 in the phases or the steps we follow in our structural model assessment. In this video, number 13, we're moving next. It is step number 2, in which we're going to assess the significance and the relevance of the structural model relationships. Calculating t-values, p-values, and checking for the relationships as well as the confidence intervals using the bootstrapping function in Smart PLS. Please stay tuned. My fellow students, let's move on with video number 13, checking for the relationships relevance in our structural model. Okay, and remember, okay, let's go back this window and go back to Smart PLS. Okay, let me remove, I was just playing a bit with the function here. Let me remove this and go back to the original model. Okay, we're studying the impact of factors impacting the online banking system use. Okay, the success factors behind online banking system use. Okay, so what we are after here is checking for the significance of the relationships among the constructs in our model, and this is step number 2 in our structural model assessment phases. Okay, we have 5 phases. Just to remind you, first phase collinearity, second phase the relationship significance. In the third phase we check for R squared, then F squared, then Q squared in step number 5. All right, so we have this model in front of us. Okay, so what we have to do first is we have to go and run the Smart PLS bootstrapping function here. Okay, so calculate and then bootstrap. Okay, in bootstrapping you can have change the significance level to 0.05 or keep it as 0.01. I'm gonna be keeping that at 0.01 here. Okay, two-tailed. Now for the subsamples, you can have it 500 or you can go up to 5,000, depending on the processing power of your computer. The higher you go with your subsamples, the more processing power needed. And if you got a slow processing power computer, then it might take a really long while to process the bootstrapping function or the results using 5,000 samples. For the interest of time, I would go with 1,000, all right? And here I want to mention, it's important to mention that if we increase our samples, we may have a better, or we would end up having a better representation of the population of data that we are studying. Okay, so higher subsamples would give a positive contribution to the reliability and maybe validity of your data. Okay, let's check partial least square. We just leave it as it is. Missing values leaving as it is, and weighing leaving as it is. Okay, set up and simply click calculate. All right. Okay, let's see here. All right. So as we notice here, in Smart PLS, I want you to notice we usually have two colors, a green color and a red color here. Let me just use the annotating function here. All right, so spotlight. All right, so we have here green colors and red color. Usually the green color indicates good, and the red color indicates maybe not good or to be rejected or not relevant or not. Okay, usually it is associated with the word no. Green with the word yes. All right. Now, how do I report my results? Simply, I would go to path coefficients. This is the tab that I am interested in for this step. And I go into Excel. I have prepared actually some table here. I'll just remove those. All right, and simply no fill in here. I was just playing with the data. All right, let me remove this and remove this as well, and then go back to Smart PLS. All right, what I have to report is simply this table, okay? And how do I report this table here? It is actually very simple. I can simply click on the Excel formula right here and then uh, go into Excel, sorry, and just paste the results. Okay, paste it. What I have here, so I would maybe paste it on this side right here. All right, let me move myself a bit. All right, so and then I pick up first what I do. If I go back to Smart PLS here, as you notice, if I go back to Smart PLS, I have the relationships right here. Okay, in this column, I have the original sample here, mean sample, sample mean here, standard deviation, t statistics, and the p-values. All right, what I'll do here, simply I'll pick up the relationships, copy, and simply paste them right in here. Okay, v, paste. All right, and so I have 8 relationships. Standard beta. What's the standard beta? It is the sample mean. All right, and I have it right here. The sample mean is right here. So simply copy, paste, and the standard error is the standard deviation. Simply copy and then paste. For the t-value, this is the t-statistics, simply copy and paste, all right? And for the decision, we'll come to the decision in a bit. For the confidence intervals, f squared and q squared, we're not gonna address this in this video, okay? We'll leave it for video number 4 and 5. Okay, next video we have r squared. Okay, but we have to look for the confidence intervals, okay? And I have to explain for you what it means here. We have 5%, this is the lower limit, and 95%, this is the upper limit. So here in this case, we have a 95% confidence interval, which means that we are 95% certain that the mean falls in the population we are studying, okay? And 5% we're not certain or it does not fall. Let me explain confidence interval. I got a reference. Let me just go to that reference and give you some explanation. All right, so a 95% confidence interval, as we notice here, let me spot the light, it means that 95% of the experiments, okay, include the true mean and 5% what? All right, so 95%, if you see in this green chart here, would include the true mean, and these were not including, and this is the upper limit and this is the lower limit. Okay, this is for the confidence interval, and in our case we have a 95% confidence interval. Okay, sometimes in some cases we may end up here we have like 10% no confidence or no certainty. Okay, and we'll end up, instead of having 5% in the upper and lower limit, we end up having 10%. All right, let's go back now to smart PLS. All right, smart PLS. Okay, to the Excel file. So uh, let's go to the smart PLS. And how do we retrieve the data for the confidence intervals? Very simple right here. Simply again, Excel format, go to Excel and let me now copy it, just paste it right here, okay? Paste it right, oh no, oh yeah, that's the paste it right here, okay? And then copy, go back to my table, okay? And this is paste, okay? So I have now the data for confidence intervals, lower limit and upper limit. I'm not gonna get those for this video. So simply, T statistics, what's the threshold? Threshold is that T statistics or the T value has to be greater than 1.96. Okay, P value, for the P value has to be lower or equal to 0.01. And this threshold, which is lower or equal to 0.01, will give strong evidence against the null hypothesis, which is H0. Okay, I'll just explain a bit more about the p-values. Right in here, I prepared as well something for you. In p-value, and according to Vice 2010, okay, p-value, if it is higher than 0.10, we have a weak evidence against H0, which is the null hypothesis. It is between 0.10 and 0.05 moderate evidence, and stronger than 0.01 and lower or greater than 0.05. This is a strong evidence, and a very strong evidence when we have below 0.01 or equal to that. And if we go and check for our p-value in our smart PLS results here, where is my p-value? All right, I will go here, and this is my p-value. Okay, it's all good, it's great, strong evidence, so we can accept our hypothesis. However, the last one, we cannot accept our hypothesis because it has a low evidence, or a low evidence, or a weak evidence, plus the t-value must be higher than 1.96, and we have it here at 1.6 only for this. So simply, this hypothesis, let me name my hypothesis H1. Okay, I'm just assuming I have 8 hypotheses here. Okay, so simply here I would reject this hypothesis. This is accept. All right, this is accept, and those would be all rejected. Okay, this one accepted, and this would be rejected. Okay, I can make it accepted or suggested or accepted. Okay, that the terminologies may differ, but they are both the same. Okay, so I now copied or reported all the data or all the results that I need. Okay, what I do is simply I can shape it a bit more. All right, maybe shape it this way. Now it looks much nicer. All right, and simply copy. All right, copy. Because in any publication or your thesis, you have to report these results. And simply I go into the Word document, not this Word document, and just paste it right here. Okay, and okay, let me just change this into landscape, so make it fit better. Okay, no, I just undo. All right, let me remove. All right, it looks much better in here, maybe a bit. Okay, so, and I can call it simply table, for instance, 5.1. If we're in chapter 5, if you're in our thesis, table 5.1, and this is hypothesis testing, or relationships significance. All right. This is has to be reported. Okay. Again, as well, what we have to report, if we go into Smart PLS, we go into the model itself, we have to report this model as well. So simply what I do to report it, file and export as an image to clipboard and simply paste it as it is right in here. Okay. So now we have the model and we got the model as well as view zoom 150. All right, we have the model as well as the results right here. Okay, uh, let me as well, I have to mention as well the t values, as we have noticed here, or in the smart PLS bootstrapping function, the t values may differ because we have different samples in the subsamples, 1000 subsamples that we have chosen. All right, this is mostly of the procedures that we have to follow, but we have to go back into the model, and I want to show you uh, if we can play with the dashboard right in here. See, if I'm looking for the p-value, I simply pick up p-value and they'll be posted on the relationships here in the arrows. I can use relative values instead of absolute values. And you see, if I use relative values, the arrow thickness will change, and the thicker the arrow, the stronger the relationship between one construct and another in this case. Okay, so the thicker the arrow, the stronger the relationship. Okay, I can play with this dashboard. Simply use absolute values, relative values, R square, Cronbach, alpha, t values, p values, etc. You can simply post or reflect whatever values that the bootstrapping function will allow you to see in this process or in this phase. All right, this is for this. Let's see what more we can see. All right, path coefficient. This is, we saw that. We can go into path coefficients histograms, okay, and we can check each relationship and pick up a histogram for each relationship and have a look. But usually histograms are not to be reported as per publication standards or thesis standards. However, in my own thesis, I've included some histogram at the end, which is in the appendices. Okay, because many histograms are reported by Smart PLS, and you may not need all of them. What else we can see? All right, that's mostly all right. So, and here I have, okay, I've done that. All right. As we report, we may, we'll come to that later. All right, we may end up using some notes for further explanations. For instance, we may end up and add a star, for instance, right here, and a couple of stars right here. This is in reporting, and then for each star I explain, and for star 2 stars I explain as well. All right, this is a part of the reporting function. All right, that would be it for video number 13. Please stay tuned for coming video number 14, in which we're going to address R squared and then R squared and Q squared in videos in the following videos. All right. Bye bye for now.